today we are going to try to talk about chapter 5 is another method. You remember we got many or at least 3 or 4 methods for solving. It was by case, by direct, by contradiction, by contrapositive, and many cases. And solving by induction, mathematical induction, which is very, very important in mathematics because it solves many original, many basic theorems for us, is mathematical induction. In the mathematical induction, we have one strategy. The first, I say I am not aware for all of them, but I'm aware about one of them. I know for the first case is true. Then I'm going to make it the generalization. I say let it be true for K. So we have case 1, look, we have case 1, we have a K, then I say if for 1 is true, for K is true, I try to show that, I try to fix or find that is true for K plus 1, like a step, step by step. So induction is like going to up, deduction going to down. Actually, we have also deduction, but we didn't mention here. Just we have a induction. So it's very important how to induct your things. You can see if you deal with a 1 and you just push 1, you know, the starting point is very important and will help you to the final point, right? You'll get from the initial point, you start to the terminal point. To understand what I'm talking about, I'm going to solve the first example. You can see from here, we have n plus 1 and over 2, okay? We have n plus 1 over 2. So how we solve that one? If I had 1, 2, 3, 4, if I want to add 1 by 1, then I will get this formula. Do you remember in the previous lecture, we say k, if I want to find the k, I say the k plus 1 over 2. This is the formula. So now show me how this one is true or not. So how we answer this question? You know how to, here's the solution. You have a basic step, and as well we have a inductive step, and then final step that we want to show that. Let me do it for you, you know what I mean. For example, I say let k be 1 for the first step. It's called basic step, okay? Basic step. So I say let be true that one for basic step. I say let k be 1. So I'll get what? I'll get 1 is equal to what? Formula, right? Instead of k, I have a 1 plus 2 till n. We say is equal to what? n plus 1 over 2. So I'm going to put k to be 1 first step. So of course at the first step I have only 1 from the left side. Am I right? How about for right side? I will get 1, understood, 1 plus 1 over 2. And I will get what? 2 over 2 is equal to 1. So left side is equal to right side. Am I right? So means that this induction is true for the first step. Now I'm going to k step. I will make a generalization to k step. So let me use one here. Look, we say 1, 2, thank you, till n is equal to n plus 1 over 2. So I'm going to solve 1 by 1. Okay. Now I say k be 1, make it k here. I say I will have just only from left side, we have only 1. How about from right side? I say is equal to 1 plus 1 over 2 is equal to 1. Left side is equal to right side. Good. Now this is the basic step. Now for inductive step, I say let that one be true till k. I suggest that this is true. I say let be true. Good. Now this is the second step. In the third step, you say what? Second step. In the third step, you want to show that. It's your turn. You should show that what? 1 plus 2 plus k plus 1 is also true. Understood? You need to show that. You should start from left side and you should get right side. How? I know this term, so left side. I see 1 plus 2 plus till k plus 1 equal to what? I see till here, by the second step, I get what? Ikaka? By the second step, till k. I say I have a k plus 1 over 2. Am I right? Because we say let that one be true. We say let be true. So that one, from the second step, I get 1. Now plus k plus 1. Am I right? Any question? Easy. Do you understand, Kaka? Good. Now, we know we need to find the common denominator. Am I right? This is common denominator. Clear? Good. And then I will get what? I will get what, Jamaat? Hey, guys? Am I right? If I take k plus 1 as a common, as a k, you can use it like that. Look, taking out k plus 1, it remains what? K plus 2. Tamam? Did I get the left side or the right side? Look, let me check. Is that the yes? You can see. We say you need to show that. We want to show that. This is true. Shall I repeat it? I say let be true for 1. Let be true for 2. I check for 1. It's true. I say let it be true for k. And I'm going to show that k plus 1. So I'm starting from left, then waiting to get the right. Did I get the right? Yes. So means that true. You solved it. Understood? Kaka? Okay. Maybe 50%. Now the second example will help you more. Look at the second example. And of course you should help me. Yalla. We have a conjecture. I'll show that's a conjecture in the mathematical induction. What's a conjecture? You say if I have 1 is equal to 1 squared. If I say 1 plus 2, I say is equal to what? The odd, sorry. If I say 1 plus 3, I'll get 2 squared, right? If I have 1, 3, 5, I'll get what? You say you will get 3 squared. So how many terms do you have? 3. You say the addition to the left side is equal to the cardinality square. You know what I mean? For example, I say 1, 3, 5, 7 is equal to what? 4 squares is equal to 16. You understand? You got it, dears? It's easy, right? So show me this is true. If you have 1 plus, right? 1 plus 3 plus 5 is equal to something squared. So how we show that? Look, here's the formula. Here's the formula. Kaka, why 2n minus 1? Why you say like that? Huh? Exactly. You have an odd, right? You have a 1. So if n is 1, I'll get what? 2 by 1 is 2. 2 minus 1, 1. If I say n is 2, I'll get 3. Understand? Why we have this formula from the left side? So for conjugator, example 2, I say I have what? I have 1 plus 3 plus 5 plus what? 2n minus 1. So n is natural number. And equal to what? N squared. How many numbers do we have, Kaka? 5. So 5 squares, 25. So how we show this one? Now we have a formula. How we show? I say first step, let n or k be 1. I'll get what? 1 equal to 1 square. It's true, right? Second step, I say what? Let be true for what? 1 plus 3 plus 5 till 2k minus 1 and is equal to k squared. Do you have any problem? I say let be true. We suggest that to be true. Our suggestion is like that. Understood? Good. Now, for the third step, what's your duty? During the exam, you should answer like that. This induction. You cannot say, come on, it's easy for the first step, okay? You should do it. This is the rule. 1, 2, 1, k, all. K plus 1. So I say, for k plus 1, I say 1, 3, 5, 2k minus 1 plus 2k. Am I right? Not plus 2. Each k plus 1. So I have what? If I have a 2k here, I say 2k plus 1 minus 1. Tamam? I will see. Is equal to what? Understood? Do you agree with me, Kaka? It's about thinking, it's not about solving actually. Yeah. And you know this one is equal to what? 1, 3, 5, 2k minus 1, and what else? Next parenthesis is equal to what? I say 2k minus 1. Do you agree with me? No. Plus 1. Am I right? 2k plus 2 minus 1. 2 minus 1, I'll get plus 1. So I'm going to use, now is ready. I'm going to use the left side. I say left side, till here. Till here, I'll get what? Who answer me? Is equal to what? No. K squared, you're right. By the second step, okay? And plus what? You have this one, we want to show that. We want to show that is equal to what? So, we say from left side, this one's k plus 2, k plus 1. Am I right, Jamaat? Are you agree with me? Tamam? This part is equal to k squared. That part just remains. And can I write this one as first square 2, first second? So this one is equal to what? Right side. Now we prove it. It's easy, 2 steps. If you actually, the important things in the third step. So we have a 1k, we then use the k. Jama'at. Understand? Good. Now is your turn. Yallah. That one is homework. Example number 4, 5 together. Yalla di. Tell me how I solve this one. N to N. Yalla. 4, 1. Yalla. 1. Tamam? Easy. We say true for what? Okay. Okay? Good. Now, we need to show that k plus 1 is less than 2. We want to show that is equal to less than 2. Am I right? Yalla. From left side. Understood? We have what? K plus 1. So what can I do? I know k is less than 2 to power k. Tamam? K plus 1. Clear. Hello? Tamam? We have a k plus 1. K is less than 2k. So plus 1 plus 1. Do you have any question? From here, you should understand. But from here, if you have a question, it's okay. From the next step. I see that one can be written as that. Am I right? If k is 0, I'll get 1. If k is 2, of course, that one's greater than 1. Am I right? Jamaat? You didn't get it? Okay. A less than B. Of course, A is less than B plus 1. Am I right? A less than B square. Am I right? A less than B plus B. Am I right? The same. We have this one as less than 2k plus 1. Tamam? You got it? So by logic we solve it, by thinking. Why? Because I want to get this. Am I right? How many 2k we have? Two 2k's. And this is equal to what? So it's equal to right side. Tamam? There was an idea. I agree with you if you say it's a little bit strange. But the previous one, example 1 and 2, it was easy. Understood here? Shall I repeat it? Kaka? Dada? No. Now, of course, example number 6 will be for you. Homework. But careful and start from where? Yeah, start from 4, right? So instead of P1, I should start with what? 4. Understood? Tamam, that's a problem that we have. That's a little bit change. Last example. If you remember, we call that one as what? We call that one as what? Yes, complement. Yeah. Yes, but if we have a using the complement with the intersection, it's called what? For example, if I have A1 intersection A2, is equal to A1 union A2 and called De Morgan's. Do you remember? Now we have, I say, show me by induction. By induction, show me this De Morgan is true. So we have, طبعا, J from 1 to N, J from 1 to N, and this J actually should be here. So we have intersection J from 1 to N, all of them. We say show me is equal to union of each AJ, J from 1 to N. Understood, dears? So how we show? We say by induction, طبعا. First, let N be. Do you think one is working? Intersections between one set or two sets. So let me start with a 2. Let K be 2. Understood? So I have what? I have, for example, A intersection B, A2, let me say A2, it's better to write that because you have AI, AJ, it's okay, the same. A1, A2, B1, the same. So A2, all of them conjugate is equal to what? By De Morgan's, we know. Am I right? Complement of A1, a union. We saw that one before, and we solve it directly. Good. Now I say let be K be true, sorry, N be 2, N be K. Am I right? So we say what? We say intersection of J from 1 to K, AJ is equal to union AJ. Am I right? Let that one be true. Do you have any comment? We say let that be true. Of course, 100%, we are going to use the first step and the second step in the third. So how about the third step? We need to a k plus 1. Yes, you are right. K plus 1. So let n be k plus 1. So I say a, j, all of them, we need to show that is equal to am I right? So how we start? I say this one can be written as okay, what else? Just let me think about K step. Okay, good, got it. Am I right? How many sets do you have, for example, to understand? For example, I have 3 sets. Tamam? Can I write like that? Can I write it? Hello? Okay, good. So, can I write like that? Or not? So, we can do it, right? Can I write like that? Am I right? Did you understand? If I have 3 sets, to understand, that's not answer actually. I'm gonna erase it. To understand, if I have 3 sets, I can say to make this one as a one package, then this is a package, let me say D. By De Morgan, we can say is what? D complement, I forget about C, sorry. D complement union C complement. Am I right? By De Morgan, if I have a 2. But my first is 2 sets. It's okay. You can apply it again. How about if I change it to the index set? I have a 1, 2, 3, like A, B, C. So I say is equal to what? 2 of them intersection. Then I'm going to apply the De Morgan for the last one. So I'll get union A3. Clear? If you understand that one, I'm going to erase it because this is not a part of the solution. So I'm going to show that here. I can write like that, understood? Equal to what? Am I right? Depending on ABC's idea. And what else? Next. This one is equal to what? By what? The second step, the previous one. She is right. We have that one. So I'm going to use it. Why we are doing 2k if we are not use it again? So we make the k, we separate it with the k plus 1 to apply the k. Now, and also red part, we have it. Am I right? And of course, I can rewrite this one as one package. Understood? We bring it to the other side, right? Did you understand what did I do? For example, if you have A union B union C, can I write like that, for example? Make it together? Yes. Now I'm going to change to A1 union A2 union A3. If I have something like that, can I join 3 to them? Why not? I see equal to what? We change only the index, right? We just bring it to the set. Depending on this information, depending on this, we did like that. We bring the k plus 1 to the set, and we change here to what? To k plus 1. And this is what? Right side. Understood? So instead of solving by case, instead of solving by contraddiction, contrapositive, we solve sometimes by induction, especially when we have an n and formula. When we have an n and formula. This is about how to solve. You can read every step, and of course you can use another homework like a union. Okay. Do you have any problem, any question?